Imagine standing on a crowded street corner, the air thick with the smell of exhaust and the hum of city life. Suddenly, the screech of tires pierces the air. A car swerves violently toward the sidewalk, heading straight for you. In that split second, time seems to warp. You freeze. Your heart stops for a millisecond, a cold void in your chest before it begins to race like a hammer against your ribs. Then, without thinking, you leap aside. Your body moved before your conscious mind could even process the danger. This is the survival instinct in action, an ancient, powerful force that keeps us alive. For decades, scientists have looked at this lightning-fast transition and wondered, how does the brain actually flip the switch? How do we go from a state of calm rest to explosive, life-saving action in the blink of an eye? It is one of the great mysteries of neuroscience. Now, a groundbreaking new study published in Science Advances is finally providing the answers. Researchers have identified two specific regions deep within the brain that hold the keys to this mechanism: the locus coeruleus and the anterior cingulate cortex. Think of these not just as simple wires, but as the brain's sophisticated control knobs, modulating our very existence. To uncover this secret, researchers turned to the laboratory, using mice to observe the brain in real time. They used cutting-edge technology, injecting a specialized virus into the mice's brains and implanting tiny fiber optics to monitor neural activity. They began by playing sounds and watching the mice's pupils. Normally, a sudden sound causes the pupils to dilate, a clear sign of arousal and readiness. But when the researchers deactivated the anterior cingulate cortex, something strange happened. The sound played, but the pupils barely changed. The mice stayed still, trapped in a state of rest. Conversely, when they stimulated this specific region, the results were dramatic. The pupils dilated wide, and the mice began to move immediately, even without a prompt. The locus coeruleus acts as the alarm trigger, sensing the world, but the anterior cingulate cortex is the volume knob. It is the decider. It determines exactly how loud that alarm should be and how long the body needs to stay on high alert. This discovery is a game changer for how we understand debilitating diseases like Parkinson's. Many patients face a terrifying symptom: movement, initiation, failure. They want to move, their mind is clear, but their bodies simply do not respond. This study suggests that in these cases, the anterior cingulate cortex may be failing to turn that volume knob up. The brain's alarm is ringing, but it's too quiet to prepare the body for action. On the other end of the spectrum, for those struggling with alcohol use disorder or chronic anxiety, the opposite may be true. Their internal alarm systems might be stuck on high volume, leaving them in a constant state of agitation and stress. By learning to adjust this specific brain region, doctors could one day help lower stress levels or restore the gift of movement to those who have lost it. We are finally peering under the hood of human nature, learning exactly how the brain tells the body to wake up, stand up, and act. The bridge between intent and motion is finally being built.